Welcome back to Precalculus. Final video for 6.2. This one's quick. I'm not going to prove this. It's pretty involved, not that it's impossible. You can look it up in the book if you want. I think it's in an appendix, or maybe you probably find a YouTube video about it if you really want to hear about it. But I'm going to just give it to you. And in geometry, we actually discussed this very briefly. Only just on a homework problem. We didn't really test on anything. But here it is. It says, if you have a triangle with only the sides, this can be any triangle you can envision. We'll call this A, B, and C. Here's an obtuse triangle. Or it could be a triangle like that. Some cute triangle like that. A, B, and C. This will always work. So here it is. The area of the triangle will be this. S. What's S, you ask? Well, give me a second. Times S minus the quantity S minus A times the quantity S minus B times the quantity S minus C. I kind of overdid my... are they going to erase? Yep, okay. That's a little nicer looking. So that's true where S equals A plus B plus C over 2. That's weird, right over 2. This is called the semi-perimeter. You know, semi means half. Like a semicircle is half a circle. So this is half the perimeter, which just seems like an arbitrary, weird thing to want to know. Half the perimeter of a triangle? Who cares? Well, if you watch the proof, you'll see how it comes up sometime. But there is an interesting point about the semi-perimeter that guarantees this will be possible. Maybe I'll close with that. But there's not much to this, so I'm just going to do one example and make a little comment about it, and then we're going to be done. So our example here will be, let's say you're given that A is 34, B is 52, and C is 28. You don't need to draw this triangle. You don't need to have an altitude. You don't need to wonder if it's a right triangle. Just plug it in. It will work. Well, the first thing I do is find S. I would like to see your S calculation. Don't just tell me what S is, since this is new. That's going to turn out to be 57. I picked kind of a nice one. It won't always be, it'll be 0.5 maybe sometimes. That's 57. So now the area is square root 57 times 57 minus 34 times 57 minus 52. And look at this. I made my square root too small this time. 57 minus 28. Okay. Probably should just do it afterwards. Okay. Put that in your calculator. I don't think we need to see a lot of work on this beyond the setup and the area. It's going to be a kind of a messy decimal because we're square rooting it. I got 436.0, and that is in units squared. There's our answer. Pretty nice and simple. If you know the formula. Here's my little comment about why the semi-perimeter is interesting. Because of the characteristics of a triangle, remember this characteristic, and if you don't want to hear this, you can just be done. This will take just a couple minutes, but because of the characteristics of a triangle, we've learned that for 3 sides to make up a triangle, the sum of the 2 shorter sides must be bigger than the biggest. That tells us that so the sum of the 2 smaller must add to be bigger than the biggest. So if you look at this, let's say A and B were the smallest ones. They must be bigger than C. So the perimeter must be bigger. Since the perimeter is A plus B plus C, this number is bigger than C, so the perimeter must be bigger than 2 times C. 2 times the biggest side. So half the perimeter, oh man, this is all squeezed in. Half the perimeter must be bigger than C, which is the biggest side. Well, this is half the perimeter. So what we just learned, the way triangles are constructed, half the perimeter must be bigger than the biggest side. Therefore, none of these can be negative. And that's when I first was learning this, I thought, how do you know that you don't get a negative in here and you can't square root a negative and somehow the area of the triangle wouldn't exist? That wouldn't work. But we've learned that half the perimeter must be bigger than the biggest side. Therefore, none of these can be negative. Therefore, the number in the square root will be positive. You can square root it. No worries. So it's just kind of a fun little thing. But this is called Heron's area formula. Really handy. From what I've read, it actually, back in the day when they were trying to find out ways to break up property, so a person died, they split into their 5 children. How do you find the area of this unusual shaped property? How do you split it into 5 or whatever? That this ability to be able to find the area of any triangle really was groundbreaking and helpful, not just in the math world. So that's kind of cool. Well, thanks for tuning in, and